Hello everyone, welcome to my channel Samvedna Psyche. In today's video, I am sharing the assignment solutions for MPC-005 research methods for IGNOU MAPC Psychology first year students. If you are part of July 2024 or January 2025 batch, this will guide you in tackling your assignments. We'll go through each question and discuss how to structure your answers effectively. Let's move directly to the answers. But before you start writing your answers, don't forget to include the front page and the question paper. Also, do mention the subject along with subject code and other details as shown on the screen. Let's start with section A. Question 1. Define sampling. Discuss the different methods of sampling. Sampling is a method of selecting a subset of individuals known as sample from a larger population or group to study and draw inferences about the whole group or population. The aim is to ensure that the sample accurately represents the group's characteristics, which allows for generalization of the results. Then you have to mention some definitions given by Young, Good and Hack, Blaylock, etc. Next, we move on to the types of sampling. There are two types of sampling methods, non-probability and probability sampling methods. We'll start with non-probability sampling methods. These methods do not allow for the calculation of probability of inclusion of each individual in the population. Although they are more convenient and cost-effective, but they may introduce bias, limiting the generalizability of the results. It includes the following categories. The first one, haphazard or convenient sampling. It involves selecting individuals who are easily accessible. While this method is quick and cost effective, it can introduce significant biases limiting the generalizability of the findings. Next one, quota sampling. It ensures representation of specific categories within the sample such as age or gender. Researchers determine the number of individuals to include from each category, but the selection is still non-random, which can lead to bias. Purposive sampling, also known as judgmental sampling, this method targets specific individuals relevant to the research topic. It's useful in exploratory research, but may introduce subjectivity and limit the ability to generalize findings. Snowball sampling, particularly useful for accessing hard-to-reach populations. This method starts with a few known individuals who then refer others, creating a snowball effect. While it's effective, it can be biased based on the initial participants' network. And the last type is systematic sampling. It involves selecting every nth individual, that is, every second individual or every third individual, etc. And from a predetermined list, starting with a randomly chosen individual. Although it offers a systematic approach, it can introduce bias if there is a hidden pattern in the list. Then second type is probability sampling methods. It allows for the calculation of the likelihood that each individual in the population will be included in the sample. Thus, it minimizes bias and enables the researchers to estimate sampling errors and makes the findings or results more generalized and reliable. The various types under this include simple random sampling, where each individual in the population has an equal chance of selection. This method is considered the gold standard in sampling due to its fairness and representativeness, but can be challenging to implement with large populations. Stratified random sampling. This enhances representativeness by dividing the population into distinct subgroups, that is strata, based on specific characteristics and drawing a random sample from each stratum. This method captures significant differences within the population but requires careful planning. Cluster sampling. It involves dividing the population into clusters and randomly selecting entire clusters for sampling. It is more flexible and cost effective, especially for large populations. but may lead to greater sampling errors compared to stratified sampling. In conclusion, sampling is a crucial aspect of research that influences the validity and accuracy of conclusions drawn about larger populations. Non-probability methods are often easier to implement but may introduce bias, while probability methods offer a more rigorous approach to ensure representative findings. Next, question 2. Discuss the types, advantages, limitations, and implications of factorial research design. Factorial research designs are essential in experimental research, particularly in psychology and behavioral sciences, as they allow for the exploration of multiple independent variables and their interactions, thus providing a comprehensive understanding of complex phenomena. Types of factorial design. Within subject factorial design, in this design, every participant experiences all levels of the independent variables, thus minimizing individual differences. For example, in a study by Gordon and Badley in 1975, deep sea divers learned a list of words in different environments and recalled them in various conditions, allowing for direct comparison across settings. You can see the example in detail along with the table I have shown, and draw this table on the left side of your assignment. Second method, between subject factorial design. This design assigns separate groups to different experimental conditions, with each group experiencing only one level of independent variables. And here also an example I have shown. An example is a study examining teaching methods and feedback types, where different groups are exposed to different combinations, thus facilitating precise evaluation of their effects. So here also you will understand it better when you'll go through the table and the example. And the last one is mixed factorial design. It combines within subject and between subject variables, and this design allows researchers to study complex interactions. For example, participants of both genders, male and female, experience various alcohol levels. This provides insight into risk-taking behavior differences based on gender. So here also I have given a detailed example along with table. Advantages of factorial design. Simultaneous manipulation of multiple variables. Factorial designs enable the analysis of multiple independent variables at once, thus enhancing understanding of the individual as well as combined effects. Increased precision and insight. By examining interactions, factorial designs detect subtle effects leading to more accurate results. Comprehensive results. They offer a holistic view by exploring multiple factors and their interactions in a single experiment. Efficiency. In research, factorial experiments can gather extensive data from fewer participants, making them cost-effective and time-efficient. And the last one, ability to study interaction. These designs are valuable for understanding how independent variables interact, which is essential for developing effective theories and interventions. Next is limitations of factorial design. Increased complexity. More independent variables lead to complex setups and analysis, thus complicating result interpretations. Challenges in ensuring homogeneous groups. Ensuring participant group homogeneity is challenging, which may affect result reliability and validity. Resource-intensive factorial designs often require more participants and resources, posing practical challenges during research. Risk of overfitting. Complexity of the design increases the risk of overfitting, potentially leading to misleading conclusions. And the last one, difficulty in controlling all variables. Managing extraneous variables can be challenging, which complicates interpretation of independent variable effects. And lastly, implications of factorial design. Understanding complex interactions. They help in exploration of how multiple factors interact, thus enhancing the understanding of complex behaviors. Insight into combined effects. These designs provide valuable insights into how different factors combine to influence outcomes. Advancement of scientific knowledge. They significantly contribute to advancing scientific knowledge by revealing intricate patterns of effects. Practical applications. Detailed results can lead to effective solutions for real-world problems by improving understanding of influencing factors. And lastly, balancing complexity and benefits. Researchers must navigate the complexities of factorial designs, balancing detailed results with the challenges of managing intricate setups. In conclusion, factorial designs allow for detailed studies of multiple variables and their interactions in one experiment. They offer precise insights but come with challenges such as complexity and resource demands, significantly enhancing our understanding of complex phenomena. Question 3. Discuss the steps involved in research process. The research process consists of a systematic series of steps that help researchers conduct scientific investigations effectively, ensuring accuracy and meaningful results. The steps involved are: Step 1. Identification of the problem. The process begins by identifying a problem or question of interest. This sets the study's direction, involving a thorough understanding of the issue and a review of existing literature to ensure that the problem is relevant and not previously resolved. Step 2. Formulating a hypothesis. After identifying the problem, researchers formulate a hypothesis, that is a tentative statement predicting the relationship between variables. Hypotheses guide the study and are derived from theories or prior research, focusing the investigation before data collection. Step 3. Identifying, manipulating, and controlling variables. Researchers define and manage the variables involved, including independent, dependent, and extraneous variables. Clear operational definitions are critical for measurement and communication, ensuring variables are accurately assessed. Step 4. Formulating a research design. A research design serves as a blueprint outlining how the study will be conducted. It includes procedures for testing relationships between variables, ensuring the design allows for the valid and reliable results while controlling extraneous variables. Step 5. Data collection. Data collection involves gathering information using appropriate tools such as questionnaires or experiments. Choosing a representative sample is essential to generalize findings. Various methods may be employed based on research question. Step 6. Data analysis. Once the data is collected, it is analyzed using statistical or qualitative techniques to determine if it supports the hypothesis. This involves testing the null hypothesis and interpreting the results in the context of the research problem. Step 7. Drawing conclusions. The researchers draws conclusions based on analyzed data, linking findings back to the original hypothesis. These conclusions provide insights that may strengthen or revise existing theories and suggest directions for future research. Step 8. Preparing the research report and publication. The final step is compiling a comprehensive report documenting the entire study, including the problem, hypothesis, design, data collection, and conclusions. Publishing the research in scientific forums allows for broader dissemination and community engagement, thus fostering further research. With this, section 1 is completed, and we'll move on to the second section, that is section B. Question 4. Describe the criteria and misconceptions of case studies. Selecting cases for a case study involves information-oriented sampling, focusing on those that provide rich insights. Extreme or typical cases are chosen over average ones to reveal underlying mechanisms. Extreme cases highlight significant issues, while typical cases provide insights into common scenarios. Researchers should uncover deeper causes rather than merely describing symptoms. Random sampling may not yield the necessary depth, making information-oriented sampling more preferable for case studies. Then, types of information-oriented cases include critical cases, which are essential for testing theoretical propositions, extreme or deviant cases, which offer insights into unusual phenomena, and paradigmatic cases, which are representative of a typical characteristics, clarifying concepts. Researchers must decide between single or multiple case studies and whether to take a holistic or an embedded approach. Misconceptions about case studies. Several misconceptions about case studies include theoretical knowledge versus practical knowledge. Critics argue that theoretical knowledge is superior. However, case studies provide in-depth understanding that aids theory development. Hypothesis generation versus testing. While effective for generating hypotheses, case studies also test and refine theories through contextual evidences. Bias towards verification. Concerns exist about confirmation bias. However, rigorous methods can mitigate this risk. And lastly, difficulty in generalization. Critics claim summarizing general propositions is challenging. Despite context-specific focus, case studies still contribute to broader understanding through careful analysis. Case studies offer detailed insight into complex issues, while misconceptions exist regarding their generalizability and theory testing role. But they are essential for understanding specific phenomena. Question 5. Discuss the different types of quasi-experimental research design. Quasi-experimental research designs are important for evaluating interventions without randomization. And the main types are non-equivalent group, post-test only design. This compares outcomes between a treatment group and a comparison group after an intervention, such as evaluating a new reading program. A limitation is pre-existing differences between the groups that may affect results. Non-equivalent control group design. This compares an experimental group to a convenience control group, like assessing a training program's impact on grades by comparing two classes which may introduce biases. Separate pre-test, post-test sample design. This uses different groups for pre-test and post-test, such as measuring customer satisfaction in separate organizations, preventing direct comparison but assessing overall changes. Double pretest design. Two pretests help control for natural changes over time, as seen in productivity measures before a policy's implementation. Switching replications design. Two groups receive different treatments that switch later on, enhancing internal validity by comparing effects across groups and times. Mixed factorial design with one non-manipulated variable. This combines a manipulated variable with a non-manipulated one, such as studying caffeine's effect on pain perception while exploring gender differences. Interrupted time series design. This tracks a single group over multiple time points before and after an intervention, assessing long-term impacts. Multiple time series design. This compares a treatment group with a control group over time, like evaluating health outcomes in community with or without an initiative. Repeated treatment designs. Treatments are applied, withdrawn, and reapplied to observe effects, like measuring outcomes during a temporary alcohol ban. And the last one, counterbalance design. This crossover design varies treatment sequence across groups to control sequence effects, thus ensuring a fair evaluation. Each quasi-experimental design offers unique strengths and limitations, providing valuable methods for assessing interventions in real-world settings. Question 6. Discuss the various threats to internal and external validity. Validity in research ensures accurate causal relationships, that is internal validity, and generalizability, that is external validity. And identifying these threats are important for robust study design and reliable results. First, we'll take up threats to internal validity. Internal validity measures how well a study establishes a cause and effect relationship between variables. And the threats are confounding, where effects of two variables are mixed, leading to incorrect conclusions due to non-random selection. Selection bias, systematic differences between groups can skew results from pre-test differences like gender or motivation. History, external events like natural disasters can influence responses, thus confounding the result. Maturation, internal changes over time like physical growth can affect outcomes, complicating causal attribution. Repeated testing, familiarity with the test can bias responses, thus threatening validity. Instrument change, changes in measurement tools can introduce alternative explanations for effects. Regression towards mean, extreme scores may move closer to the mean, falsely suggesting changes due to the independent variables. Mortality, dropout rates can bias results if dropouts differ systematically from the participants who remain. Diffusion, treatment effects spreading to control groups can reduce observed differences. Compensatory rivalry or resentful demoralization. Changes in control group behavior can impact results. Experimenter bias, researcher expectations may unintentionally influence outcomes which can be minimized through blinding. Then, threats to external validity. Threats to external validity. External validity refers to the generalizability of results, and the key threats are aptitude, treatment, interaction. Results may not generalize if sample characteristics interact with the independent variable. Situations, study conditions may limit generalizability. Results from control group settings may not apply to real world scenarios. Pre-test effects, relationships may be specific to pre-test conditions, thus affecting generalizability. Post-test effects, results may only apply to conditions influenced by post-test. Rosenthal effects, researcher expectations can skew results, thus affecting generalizability. Question 7. Describe the various instruments used in collecting data through survey research. The various instruments are utilized to collect data efficiently, and it includes sampling techniques, questionnaires, and interview. Let's start with the first one, sampling techniques. Sampling is vital for selecting a representative subset of a group or population to make inferences about the entire group or population. And the main techniques under this are random sampling, where every member has an equal chance of selection, thus reducing the bias and enhancing generalizability. Techniques like lottery or fishbowl methods are commonly used. Stratified sampling. Here the population is divided into subgroups based on characteristics like age or job role, ensuring representation across different segments for improved accuracy. Next method is questionnaires. These are widely used for data collection from many respondents, consisting of structured questions answered in writing. It includes mail surveys, where questionnaires are sent via mail for respondents to complete and return. This method is cost effective but may not suit questions which need immediate responses. Group administered questionnaires. Respondents complete questionnaire in a group setting in the presence of the researcher, thus enhancing response rates through immediate feedback. Household drop-off surveys. Here researchers deliver and collect questionnaires from respondents' homes, allowing for personal interaction, but it is more time-consuming. And the third type, interviews. Interviews involve direct interaction between the researcher and the respondents, allowing for detailed responses. The various types of interviews include structured interviews, where a predetermined set of questions is asked in a specific order. This provides consistency for standardized data collection. Unstructured interviews. This flexible approach allows for conversational engagement and is useful for exploring complex issues and gaining deeper insights. Telephonic interviews. conducted over the phone, they save time and are cost effective, but it may not include those who do not have phone access, and this limits the depth of the responses. Each instrument has unique benefits and limitations, making the right choice depends on the researchers, and that is essential for effective data collection and achieving research objectives. Question 8. Explain the different types of variables. In psychological research, variables are categorized to helping study design and analysis, and the key types are stimulus, organism, and response variables. Stimulus variables are external factors like light, sound, crowd that organisms respond to. For example, an electrified grid shock in a rat experiment. Organism variables are internal characteristics of the organism, such as anxiety or physiological states. For example, a rat's skin resistance during experiment. Response variables are behaviors or actions in response to the stimuli, like the time. For example, how much time the rat takes to jump from the grid. Independent and dependent variables. Independent variables are manipulated by researchers to observe their effects, such as different noise types in a task performance study or different levels of noise. Dependent variables are the outcomes measured to assess the impact of independent variables, like task performance quantified by the frequency or duration. Extraneous and confounded variables. Extraneous variables are the variables other than the independent variables which can affect the dependent variable, and these should be controlled, such as environmental conditions during an experiment. And confounded variables, confounding occurs when two variables are mixed, complicating the ability to separate their effects. For example, age differences in smoking and heart disease studies. Active and attribute variables. Active variables are manipulated by researchers, like teaching methods or reward levels, which influence experimental conditions directly. And attribute variables, they measure characteristics such as intelligence or socioeconomic status, which reflects the inherent traits. Quantitative and categorical variables. Quantitative variables vary in amount and include measurable attributes like speed or illumination levels, while categorical variables vary in kind, including categories like gender or race, which can be constant, dichotomous, or polytomous. Continuous and discrete variable. Continuous variables are measured with fine precision, such as age or height, and this allows division into smaller units. While discrete variables have distinct categories with gaps, like the number of family members or books. Understanding these variable types is crucial for effective research design and interpretation of results. Let's move on to section C now. Section C, question 9. Ex post facto research. Here you have to describe how it studies pre-existing conditions to understand cause and effect relationships without manipulating variables. And also that it compares groups for understanding past phenomena. Question 10. Steps of evaluating data in qualitative research. Here outline the key steps like reading data, categorizing it into themes, labeling categories, identifying patterns, and recording the analyzed data for future reference. Discourse analysis. Here discuss how it examines how the language constructs meaning about society, events, or individuals. Also mention methods like semiotics and narrative analysis used in this process. Question 12. Strength and weaknesses of field experiments. Mention that field experiments allow for studying real-life behaviors but can face challenges like extraneous variables and researcher bias. Question 13. Types of constructs. Discuss the two types of constructs, intervening variables, which summarize other constructs, and hypothetical constructs, which are theoretical but have measurable characteristics. Question 14. Causal comparative research design. Explain how it compares groups to explore potential cause and effect relationships, though it lacks control to draw definitive causal conclusions. Question 15. Objectivity safeguards. Here mention how using procedural safeguards, standardization and operationalization ensures objectivity, along with minimizing bias to enhance research accuracy. Question 16. Research biases. Here outline the different types like personal bias, observer bias and expectancy bias, which can distort research data due to researchers or participants' expectation. Question 17. Memory effect. Describe how memory effect occurs in test situations where participants recall previous answers, leading to artificial reliability in results. Question 18. Content analysis. Mention that it's a method for summarizing and quantifying content by coding and counting textual elements. And it allows for the detection of trends and patterns over time. Here I am wrapping up this video. I hope these solutions make your assignment process smoother. If you have any questions or need further help, drop a comment below. Make sure to share this video with your friends who might benefit from it. Keep focused on your work, and I'll see you in the next video with more content.